Integration by Parts, Part 2, Basic or Typical Examples. Recall that there are some indicators that tell us when we should use or should probably use IVP, and the indicator that I look for is my integrand a product of some of these functions? So what if I had the integral of, say, x times natural log of x dx? Well, I know from experience and because of my indicator that this is an integration by parts problem. So I have two choices. I could either let x equal u, which would give me dv is whatever's left over, or I could choose natural log of x equals u, and then dv is whatever is left over. Remember that we are given the integral of u dv, which equals uv minus the integral of v du. So given u and dv, we choose which is which. I need to find v and du. So let's look at my first try. If u is x, then du is dx. Very simple. If dv is natural log of x, then v is, I don't know. Or at least at this point, we don't know how to do it. So that's an indicator to me, a separate indicator, that I probably chose incorrectly. And that this bottom one is probably going to be the correct choice. If u is natural log of x, then du is 1 over x dx. And if dv is x dx, then v is x squared over 2. Now, it may seem that I made things more complicated, but at least I could find both v and du. Now, if I plug into my equation below, I get the integral of u dv is u times v. I'll put the v first, x squared over 2 times natural log of x, minus the integral of v times du. If I multiply v and du together, one of the x's will cancel, and I'll end up with x over 2 dx, which is a very solvable integral. Finishing this off, I would get the integral of x times natural log of x is x squared over 2 times the natural log of x, minus the integral of 1/2 x, which is going to be x squared over 4. And at this part, or this point, we can put the plus c. Let's take a look at our next example. Let's do the integral of the arctan of x dx. Now, I know this is integration by parts. Be careful, we're doing the antiderivative of arctan. We're not doing the derivative of arctan. So I will start again by finding my u and my dv. I don't really have a choice. I mean, I could I suppose let u equal dx, but then what does du equal? I mean, I have no idea. So I really only have the choice of u equals the arctan of x. Okay, so we do have to take the derivative here, but that's not the end goal. So the derivative of the arctan of x is 1 over 1 plus x squared times dx. And what does dv equal? Well, dv is what's left over, which is dx. because I already used everything else, which means v has to be x. And then the integral of u dv, I like to write it over and over, it just gets into your long-term memory better, I hope. Integral of u dv is uv minus integral of v du, and then we can plug in u times v, I wrote it as v times u, minus the integral of v du, which would be x times 1 over 1 plus x squared dx, but I wrote it as x over 1 plus x squared dx. And let's see if we can integrate this back piece. So this back piece is a u substitution. Okay, I already used u, so let's call this a t substitution. I'm going to let t equal 1 plus x squared. And then dt is 2x dx. If you don't remember how to do integration by substitution, go ahead and go look at the video that I did on this. So I have t in the denominator. I have almost all of dt in the numerator. I need a 2 to fix it, which means I need a 1/2 also. And then rewriting, I get minus 1/2 the integral of dt over t. Convince yourself that is what you get. And then we can go ahead and integrate that back part. So I get the integral of dt over t, which is the natural log of t. And I'll just go ahead and plug in t back there. No absolute values needed because 1 plus x squared is always positive. And then we can put our plus c at the very end. How about a more complicated seeming one? And we'll see it is a little bit more complicated. Let's do the integral of x squared times, let's say, just e to the x. We'll keep it simple for now. This is definitely integration by parts. It meets my indicators. Experience tells me it is. I'm going to choose u to be x squared, because why not? And then dv equals e to the x dx. If I chose incorrectly, we'll see somewhere down the line. Or maybe not incorrectly, maybe poorly is the better word. U equals x squared gives me du is 2x dx. dv equals e to the x, meaning v is e to the x. And then the integral of u dv is uv minus the integral of v du. So we can plug in uv x squared e to the x minus the integral of v du. Okay, you might think I chose poorly, but I actually chose wisely in this case. This integral here is somewhat simpler than that one, but it's still an integration by parts, which tells me I have to do it again. Now, technically, I should use different letters, because I already used u and v above. I should use maybe t and s, but I found that sometimes use so many letters it gets really complicated. So I'm going to use u and v again, just knowing that this u and v are different than the original. And so I'm looking at this being u times dv back here. So if I let u equal 2x, since I let it equal x squared to start, I'll kind of keep in the same vein. And then dv is e to the x dx. I need to find du, which is 2 dx. And I need to find v, which is e to the x again. So my integral is x squared e to the x. That is my original integral, is x squared e to the x minus, okay, all of this back stuff, which is my new uv minus my new integral of v du. So I'll plug in, I get x squared e to the x minus new uv. And then I have minus a negative, so plus the integral of v du, which is a very, very simple integral to do. Let's finish this off. The integral of x squared e to the x is x squared e to the x minus 2x e to the x plus the integral of 2 e to the x, which is 2 e to the x. And at this point, we can put the plus c. You might be thinking, is there an easier way to do problems like this? The answer is yes, and we will see that in the next video.